All right, here we go. The last section of this chapter. It's exciting, isn't it? Does it seem like it's taken a long time or a short time to get to here? Short time? Yeah, I think so too. We skipped one or two lessons though, didn't we? Yeah, so that's all right. All right, let's take a look at this. What in the world is this thing? This is a three-dimensional figure, so 3 dimensions. Now, sometimes it's hard. Thank you. Sometimes it's difficult to draw something that's three-dimensional on a two-dimensional space, okay? So we're using the screen right here. That's 2 dimensions. It just has a height and a width. It doesn't come out like this, does it? All right? But we kind of draw it in a way so you can kind of understand what it's doing. So basically, is this just a plain old circle, do you think? No. What is it basically? Yeah, we call it a sphere. And the sphere, it's three-dimensional. It comes out. It's got some depth. So really, if you really saw that in real life, it would like come out like this, right? That's what like 3D movies. You ever watch a 3D movie? Sometimes you put the glasses on and stuff, right? And it looks like it's coming out at you, right? That's that third dimension. And so that's what it is. Basically a ball, basketball, soccer ball, you know, something like that. Not football, okay? But football, softball would be a sphere. Now, technically, they're not really spheres because they got little indentations on them. It's not a perfect sphere, but you get the idea, okay? It's basically things that we see every day that resemble a sphere. So let's write that word down before we go to the next one. So it's a funny sounding word, S-P-H-E-R, oops, I said E, I wrote a R, E-R-E. Okay, it's a sphere. We don't have many words that do that, do we? Sph, like that. Usually we'll have a vowel in there so somewhere, wouldn't we? But a sphere, anyway, that's what it is. So basically, I'll just read the definition. I'm not going to write it down. I'm not going to ask you to like give me the definition or anything like that. I'll just read it. It says a sphere is a set of all points in space. So it's not just in 2 dimensions. It's all in space. Space means everything around us, okay? So if you have a point right here, okay, it's the given distance from that point. Let's see how they say it. In a space, it's the set of all points in space that are a given distance from a point which we call the center. So this point right here, we talked about that on a circle as well, didn't we? We said that that was the center. But it's the set of all points in space that are a given distance. It's not just in the 2 dimensions. It's not just from here to here. It would also go like from here out, wouldn't it? So technically, that would be a radius. But you're looking at it, you're like, well, that radius looks a lot shorter than that. But really, this is kind of like a slanted circle, isn't it? So this thing right here, it looks oval-ish, doesn't it? Everybody see that? But in reality, it's 3 dimensions. So what is that supposed to represent? It's like if you cut that sphere right in half, right? And then you get a circle, wouldn't you? So it doesn't look like a circle, does it? It looks like an oval, but it's technically a circle. So really, that radius and this radius would be the same. It's just because that circle slanted a little bit, so our point of view is a little bit different looking at it. Does that make sense? Yeah. All right. So, and if I, you could do that radius everywhere. So if I have a point and I have a certain radius, let's say, 10 inches, okay? So here's the center, 10 inches here, 10 inches everywhere. If I took it out 10 inches from that one center point, everywhere in every direction, you would eventually, if you do it enough times, it would eventually make a ball, wouldn't it? It'd make a sphere. Make sense? So that's what the definition is, and that's a sphere. So it does have a center, it does have a radius, and that's pretty much all you need to know at this point right now. Later on, there's a chapter. I don't even know if we're going to do that chapter or not. There's a chapter about finding the volume and the surface area of things. You ever hear about that? You've heard about finding the area of something, right? If you want to find the surface area, there are formulas, there's equations and things like that to find that. We're not going to hit that right now. We're just going to say this thing's a sphere, it's got a radius, it's got a center. It's basically all you got to know. Everybody good with that? Okay. All right, let's see what the next one is. All right, what's that thing look like? Yeah, exactly right. It is a cone. Now, look at the bottom of it. I'll just put a little arrow right here. What kind of shape is the bottom of it? Again, it looks like an oval, but it's three-dimensional. So yeah, it's a circle. So the bottom is a circle. Look at the height. The height is from the top all the way to the bottom, and that would be the center of it, wouldn't it? Right there, the center of the bottom. And then it's got a radius. Instead of calling it the bottom, we're going to call it the base. So that's the, yeah. So yeah, again, a lot of this stuff is probably not brand new to you. Some people it might be. For some, it's not. It's stuff that you've probably talked about at some point in your math career. So we call this the base, this whole thing. That would be a circular. So this is not just any old cone. Look at the height and the radius. What kind of angle do you think that forms? A right angle, that's right. So if you wanted to be really specific about this, you could just say in general it's a cone. But if you want to be really specific, we call it a right circular cone. Everybody see that? Why the word right? Because the height and the radius are perpendicular, right? Did we use that word perpendicular? Yeah, they're perpendicular, which means it makes a right angle. Okay, it's circular. Why is it circular? Because the base is a circle. And it's a cone because, now watch, these sides don't go straight up, do they? That's something else we'll talk about in a few minutes. They go to a point. See that point right there? I believe they call that point a vertex. Let me just double check. Do they say that somewhere?
In the definition of cone.
What page?
39.
Okay, I'm looking right at it. Yeah, to the curve. Yep. So this point right here is called the vertex. So a cone always comes to a vertex. It comes to a point, one single point.
So could pyramids be classified as cones?
They could be, but we use pyramid because the shape of the base is different, so we actually give it a different name. But that's a good observation. We call this a cone because the bottom of it is a circle, okay? So when the bottom or the base is a circle, we call it a cone, all right? And we will get to that. We will do a pyramid in a little bit. That's a good point. All right? Everybody good with that? Let's see. H, I said it already. What's the H? It's the height. And the R is the radius, okay? Now, the height is perpendicular to the base, all right? If it's perpendicular to the base, we always call it the height. We'll talk more in detail about that another time. Not every we'll do cylinder in a minute. Not every cone is a circular. I don't even know what order I have these in. Let me see. Okay, here. Yep, this is what I want. Oh, what is that thing? Good question. Well, it has some similarities, doesn't it? Is this thing a cone? Yeah, it is. Okay, why? Because the bottom is a circle, the base is a circle, and it comes to a point which is called the what? The vertex, okay? Everybody with me on that? But is it a right circular cone? It's not, because it's slanted, isn't it? Do you see how it's slanted? And the height, this thing right here, do you see that distance? That's really not the height. In order for it to be the height, it has to be perpendicular. But that distance from the vertex to the base is not perpendicular to the base. Do you see that angle right there? That is not a right angle. Okay? So we call this an oblique. It's a weird word, isn't it? An oblique circular cone. Let me just double check. I don't want to mess this up. Let's see. Do I even have this in the book?
Yeah, I see it. Well, then it's oblique circle cylinder.
Right. So you have an oblique cylinder, but before you got to cylinder, though, I don't know if I want to call this circular, because that may not possibly be a perfect circle. Let's just call it an oblique cone. Is that all right? Why is it oblique? Because the side is slanted. It doesn't go straight up. See that point, that vertex? It's not directly above the center. All right? So this is not coming down. Now, right here, it looks like that's a right angle right there, but this one's slanted. Do you see that? All right? So, and I don't even care about this one being slanted. It's this one right here. From the vertex to the center, That's slanted. That's not a right angle. So that's not a right cone. It's not a right circular cone. We call it oblique. All right, so when it's slanted a little bit, it's oblique. You ever do anything in Word with letters and stuff, and then, yeah, if you want the letters to slant, what do we call that? We call it italics. Now, I have a program. There's a desktop publishing program, kind of like Word. It's a lot better. It's for like professional people that design magazines and stuff like that. They don't call it italics. They call it oblique. So whenever you want to make something italics, they call it oblique. All right, it's kind of interesting because I think Word probably still calls it italics. Is that correct? All right, but some programs call it oblique, and that's what it means. It just means you took the letters and you slanted them. All right, and it's kind of like this. You took this cone, this right circular cone, and you just slanted it. All right, we good? All right, so that's cones. Look at this one. Now, a couple of guys mentioned it already. What do you think this is? Yeah, this is a cylinder. All right. Make sure you spell these correctly. Spell oblique correctly. You wouldn't believe some of the spellings that I've gotten when people write the word oblique.
It doesn't sound like a Q. It sounds like a C.
It does, but sometimes the Q, U, doesn't always sound like qua. A lot of times it's a ka sound. I don't know, I can't think of anything off the top of my head. Can you think of a word with a QU that sounds like ka instead of qua? What is it? Quake?
Quick.
Huh?
Quick.
Quick? Well, you still got the qua. A QU that doesn't sound like a qua. Albuquerque. Very good. Love it. All right. Albuquerque, New Mexico. I think it's the capital, or it's the biggest city anyway, in New Mexico. Anyway, so that's good. But yeah, there are some words that do that. They're not all qua sounds. But that one, yeah, it sounds like a K or a C, but it's oblique. Got it? All right. Well, here's a C that doesn't sound like a K, does it? The C sounds like an S. English language is really weird, isn't it? Sometimes it sounds like this, sometimes it sounds like that. We're so used to it. But for our friends from China here, they're probably looking at English and say, man, what a weird language. You ever think that? Yeah. I mean, it is when you think about it, and you think of all the weird, like, there's silent E's and there's silent this. Like, why even put the letter? If it's going to be silent, why put it in there? I don't know. It's just the way they do it, but it is kind of strange. All right, let's do this. So this is a cylinder. Now look, it's the bottom. What kind of a shape is the bottom of this? It's a circle. But this time, it doesn't come up to a vertex, does it? The sides go, what? Just straight up and down, okay? When we say straight up and down, we're saying they go at a, whoops, I'll tell you what, let's make it nice. What kind of angle? At a right angle, okay? So this goes at a right angle. So this is straight up and down compared to the base, all right? So that would be the height. Now this would be the height as well, wouldn't it? From here to here, would you agree? Yeah, it's the same as that, because it just goes straight up. All these heights are parallel to each other. All right, so that is a cylinder. So we call this a base, and a lot of times you're like, okay, it's called a base because it's on the bottom. Any cheerleaders in here? Aren't the girls at the very bottom are the what? They're the bases, okay? So that's kind of right here. But look at this. Now, we don't call this the flyer, right? Since they're on top. But we also call that the base as well. It's kind of weird because the base is on the bottom and the top, so we don't call it the top or anything like that. We still call it a base because this shape on top is the same exact shape on the bottom. Everybody with me? Yeah. All right. And of course it has a radius because this is a circle and that's a cylinder. Let's see if I have another one. Oh, I do. Look at this. I put them in pretty good order, I think. Oh, by the way, I should have been a little more specific. I knew I was missing something. It's not just any old cylinder. If I was going to be really specific with this and give as much detail as I could, if I was going to describe this, would I just say, oh, this thing's just a cylinder? Now, you can have a lot of things that look like a cylinder, but maybe not look like this. Like we did that, that cone, what do you think I could call this? The bottom is a what? It's a circle, and it goes up at a right angle. So what do you think I'm going to call this? It's a right circular, right? Since the base is a circle, so it's a right circular cylinder. So that's, if I was, this particular one would be called a right circular cylinder. Is every single cylinder a right circular cylinder? No, because I got one right here. That's still considered a cylinder, but what do you think we're going to call that thing? It's oblique. That's right, because look at the sides. They don't go perpendicular to the base. Do you see that angle right there? Watch, if I was to put that line right there, look at the side and look at that diameter or that radius, right? If I started it from there, that would be the radius. That is not a right angle, is it? All right, so it slants. It doesn't just go straight up and down. So what word do you think I'm going to call this? Oblique, right. Now, in the book, they do call it an oblique what? Circular cylinder. So I might have been okay with that cone, that oblique cone, calling it an oblique circular cone. I just wasn't 100% sure, so I didn't say that. All right, so that would be an oblique circular cylinder. Basically, all you're going to have to do with these things is I'm going to give you the picture, and you're just going to have to tell me what it is. That's it. Okay, so on a quiz or a test, you'll have 2 or 3 of these maybe, and you just have to tell me what shape it is. All right, but be specific, and it'll say something about like, give me the most specific name for this particular figure. All right, so if all you said was just cylinder, is that specific? No, you would say oblique circular cylinder. Same thing with this. Just calling this a cylinder is not specific enough. So you got enough information on here to say that it's a right circular cylinder. So that's what we would call it. Everybody good with that? All right, look at these. These kind of look like cylinders, but they're not quite cylinders, are they? Let me see something. Give me a sec. Just want to make sure I say this correctly. Okay. So it kind of looks like a cylinder because the sides go straight up, don't they? And the base, the 2 bases are the same. But look at the base. It's not a circle this time. What is it? Yeah, it's a rectangle. Okay, you could have different shapes. You could have a pentagon as the base of it. You could have a hexagon, as many sides as you wanted. All right, and if all the sides go straight up, it would kind of be like a cylinder. But we use a different word. We don't use cylinder this time. Since the bottom is not a circle, but the sides go straight up, does anybody know what that word is?
Prism.
It's a prism. Okay, so we call this a prism. Now, we got to take a look at the bottom. Sometimes the bottom might be, like I said, a heptagon or an octagon or a decagon or something like that. This one happens to be a, what, rectangle. You see that? Now, it may be a square, not really sure. It's hard to tell if we don't measure it, but we can say a rectangle. So I would call this, what do you think? The sides go straight up, so it is a right angle right there. What would I call this? A right rectangular what? Prism. Make sense? All right. Why is it right? Because the base and the height are perpendicular. Makes a right angle. So that's why it's right. Why is it rectangular? Because of this base. That base is a rectangle. And it's a prism because the bottom is not a circle, but the sides do go straight up. And the top and the bottom, the 2 bases, okay, are exactly the same. What about this one? What's the difference between this one and this one? This one's oblique. That's right, because the sides slant. So this is an oblique. Now, you wouldn't say right, would you? Because you already said it's oblique, but you could say the bottom still looks like a rectangle. So you could say rectangular prism. What about this one? This is a little different. What's just a little bit different about this one compared to this one? Look at the base. That's right. The base is a triangle. That's right. So, but the sides do go straight up and down. Now they didn't put the right angle mark thing, but I will. Okay, the sides go straight up and down to the base. Okay, it's perpendicular. So what would I call this one? A right. Now, I wouldn't call it a rectangular. Why not? Because the base is a triangle. So what do you think I'm going to call it? A right triangular prism. So they're all basically the same kind of shape, right? Generally, very generally, but you can be a little bit more specific with each of these three. Again, you could have a bunch of different lengths of the side, or not the lengths of the sides, but the number of sides for the base. You could have 5 sides, 6 sides, 10 sides, 100 sides, 1,000,000 sides, okay? But that's what we're going to call those. Everybody good so far? All right. Now, what do you think we're going to call this? This is a little different. So this is not a prism. Why not? Because the sides don't go straight up. And look at the base. It only has one base. It doesn't have a second base on top, does it? But it does come to a point, which is a vertex. So what do you think? But the bottom is not a circle. So it kind of resembles a cone, like we first talked about. But the bottom is not a circle. Somebody's already mentioned it before. What do you think we call this? That's right. This is a pyramid. Okay? And if I was to drop this straight down, and then go straight across, well, I'm kind of pretty close. It's not exact, but it's close enough. Look. See that? That would be the height. It would be straight down the bottom. If it's a right angle, it hits the base at a right angle. That would be, what do you think? A right. What kind of base does this have? Rectangular. We're not really sure it's a square because I don't know exactly if this side is exactly the same as this side, but we could call it a rectangle. It's a right rectangular what? Pyramid. Everybody good with that? There we go. You see these sides right here? See how I'm kind of shading in? Everybody see that? How many sides does this have? 1, 2, 3, 4, then the bottom, right? If you want to call the bottom a side. But we call the bottom a base. So if I just stick with the sides, how many sides does this have? That would be a side, right? That has 4 sides. Because it's got how many sides on the base? 1, 2, 3, 4, right? The base is a rectangle. It's got 4 sides. So it's going to have, actually, you know what? Do they call it a side? I think they call it a face. Let me see. Depends where you're learning from. Let me just see what it says. I don't think it says in here at all. Oblique. Da, da, da. Oh yeah, it does. Okay. So let's. Some places do call it the side, but we're going to call this the face. All right. We got the face. We got the base. So how many faces are there? 1, 2, 3, 4. There's one base, one vertex. There's a radius. There's a height. Okay. All kinds of stuff to know about that. All right, let's see what else we got. All right, that kind of looks like it. Let's go a little smaller. Actually, let's do this. Yes.
Varsity cheerleaders get dismissed at 2:30 on Mondays.
Work with the little ones.
Yeah.
All right, I guess you have to go then. 'Cause cheerleading's.
Announcements, but you weren't here for that.
I wasn't. What are you trying to say? Trying to say I was late?
No,
I'm just messing with you. That's fine. Cheerleaders can go. All right, so what do we got here? Look at the vertex and look at the base. Does it look like it makes a right angle to the base? No, it looks like it's slanted, right? So what's the first thing we're going to call this? Oblique. All right. Now, it does come to a point. So what do we call it when it comes to a point? Well, not when the bottom's not a circle. Only a cone when the bottom's a circle. What is it? Pyramid. So I'm going to leave a blank right there. Pyramid. Now, what kind? Pyramid. Okay. Now, look at the bottom of it. Is it rectangular? Is it triangular? What is it? How many is it? There's 1, 2, 3, 4, 5, 6. Yeah. Hexagonal is how we would say it. Okay? Hexagonal.
Wait, can we write the, you see the, but there's a chart with the polyhedrons.
Yeah, we're going to look
Put
at
that in our notes.
we're going to look at that in a second. Okay? So oblique, hexagonal, pyramid. All right? So what am I going to do on a quiz or a test?
Ask us to name it.
Yeah, I'm just going to put the picture on there and you just name it. All right? But you got to name it its most specific name. And that's what that would be. Make sense? You know the difference between a pyramid and a cylinder and a, what was the other one? Prism and cone. All right? Make sure we know the difference between all of those. All right? This is a pyramid. Why is it a pyramid? Well, first of all, it doesn't have a circle as a bottom. All right? So it's not a cone. But it does come to a point. It comes to a point, it's a pyramid. What if the sides go straight up and the base, the two bases, the bottom and the top are the same? What do we call that thing? And the sides go straight up. That's a, well, in general. So you got a base, whatever it is, okay? Let's say it's got a certain number of sides. It's not a circle, all right? And the sides go straight up. It's not a pyramid, it's a, what's the other one where the sides go straight up? Starts with a P as well. Prism, right. Okay, that would be a prism. So make sure, a lot of people get them mixed up, and I got to think about it sometimes, okay? I only do this once a year, so I don't remember it every single day. But a pyramid and a prism are different. A pyramid does what? It comes to a point. Okay, a prism, the sides go straight up, right? Now, they don't always go at a right angle. Sometimes they're slanted, but when you got a base on the top and a base on the bottom, that's when you have a prism. When you just have one vertex at the top, then it's a what? Pyramid, all right? All right, now I think we're getting into the weirds. Oh, I didn't put all those other shapes on there. Let me see. I know I got a file. I thought I had all those on there. Let me see. 6, school, geometry shapes. Oh, here they are. I'll tell you what. Yeah, might as well. It'll take me a minute here, so just bear with me. I'll tell you what, let's get rid of we did all that writing afterwards. So let's keep going until that, maybe won't be able to because I don't have enough space on there. Let's do this. Let's get rid of this stuff. Give myself some room. Get rid of this. All right, that should work. All right, we'll just do one at a time instead of sitting here doing them all. Yeah, let's do this one first. Okay. Yeah, it's good enough. All right, so this, let's make it a little bit smaller so I can fit it in here. There we go. All right, so this thing is called a what? What's that word? Tetrahedron. Tetrahedron, okay? So these are your hedrons or your hedrons, however you want to say it. If you, we could call them poly. What's the prefix poly mean?
Many.
Many, right. So hedrons. All right, so polyhedron, let me just read it off to you. may not make sense, but maybe looking back on it, you're like, oh, okay, I think I know what they're talking about now. So polyhedron is a closed surface made up of polygonal regions. These are all polygons. Do you see that? That's a triangle, triangle, triangle. They're not always all triangles. In this situation, they are. You don't have to know any definitions. I don't make you write down any definitions. Okay, I'm just saying it so we can see that this is what it says it is. All right, and it says each polygonal region forming the surface is a face of the polyhedron. So this is a face. That's, oh, I got it right there. I didn't even see that. Okay, you got a face. That would be a face. That would be a face. Each one. How many faces does this thing have? 1, 2. Then you got one on the back, right? And then you got this one down the bottom. All right, so yeah, it's got 4 faces. Now, it doesn't just have one vertex. It's got 4 of them, right? It's got 1, 2, 3, and 4. And the edges, what are the edges? The edges are these straight lines right here. Everybody see that? Where those faces come together, they're line segments, so that's an edge. How many do we have here? 1, 2, 3, 4, 5, 6. So we got 6 edges. All right, so that's a polyhedron. And we do have a whole list of them. On page 41, there's a whole list of them. And 4, 5, 6, 7, 8, 9, 10. So we go 4, 5, 6, 7, 8. 9, 10, and then they skip a little bit. They go 12 and 20. All right, so here you go. Everything's going to end in the word hedron, okay? So all you got to know is your prefixes. If you know your prefixes, then it's pretty easy to figure out. So if you had 4 sides or 4 faces, this has 1, 2, 3, 4 faces. What do we call this thing? A tetra, right? Tetra sometimes is a prefix for 4. So that would be a tetrahedron. I'm not going to write hedron on the end of every single one of these. Everyone's going to have that on there, okay? So what is the prefix for 5? Pentahedron. So that's a pentahedron. And then 6 is just like we did when we did the regular shapes, the 2-dimensional shapes. It's a hexahedron. What word did we use when we did the 2-dimensional shapes? Did we use septa, septagon? Yeah, this one uses hepta. I think I told you back when we did that one, sometimes people use hepta, sometimes you use septa. That book happened to use septa. This one right here, though, for the hedron, they use hepta. It's a hepta what? Not a gon, but a what? Hedron. Every one of these, right, is going to have a hedron next to it. 8's an easy one. What's 8? Octo, right, like an octagon. So a lot of these are the same as we did before, the prefixes, but you just stick hedron after it. 9 is a nonahedron. It's kind of weird, N-O-N-A. So nonahedron is 9 sides. 10 should be easy. What's 10? Deca, right, like decade, right? Did you ever think of that? Decade is 10 years. Deca. Right? So decahedrons, 10 sides. Then you got 12, which is dodeca. Dodecahedron, right? All the hedron goes all the way down to here. And 20 is kind of weird. Icosahedron. Right? So if you know those prefixes, it should be pretty easy to figure them out. That's in the book on page 41 if you want to look. I'm going to skip ahead a little bit and throw a couple on here. So let's just do this one. All right, there we go. So how many faces does this have? Now remember, it's got a back to it too. You just can't see them all. So you got 1, 2, and then 3, 4. Look, it's a 1, 2, 3, 4. So it's like a square or rectangular base, right? So it's got 4 on the top and where? 4 on the bottom, 8 altogether. So what do we call this thing? Octahedron, right. This would be an octahedron. You got that? All right, let's do another one. So let's get rid of this. Let's do this one. Okay, great. Thank you so much. What about this crazy one right here? Well, let's make it a little smaller so you can see it. Of course, I already cheated because I put it right here, didn't I? All right, anyway. Let's count. Ready? Let's just count these faces. Now you got all these lines in here as well because I guess it's like the back of it, right? So you can kind of visualize the back. But really, if you just look at the front of it and just double it, all right, that's how many there are. So how many faces? 1, 2, 3, 4, 5, 6. So there's 6 that you can see, but then you turn it around and guess how many there are? There's 6 on the other side, so how many altogether? There's 12. So what do we call this? A dodecahedron. Or I could just slide this thing up and they tell you it's a dodecahedron. Why do they use the word regular? Because each of these faces is a regular 1, 2, 3, 4, 5 pentagon. So each face is actually a regular whatever polygon it is. In this case, it's a pentagon. All right. And let's do one more. Do we have any room? Yep, got a little room. Let's do this crazy one.
Can you tell where the back is?
I know, but all we got to do is count up how many that we see and then do what?
Multiple.
Just double it. Okay. So let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So there's 10 that we can see. So how many are there altogether? There's 20 sides. So what do we call a 20-sided icoso? Icoso, however you want to say it. Icosahedron. That's pretty easy, isn't it? Just got to go through them again and look to see what they look like, what the names are. Don't get confused between a prism and a pyramid. All right, make sure you know if it's oblique or if it's right, all that kind of stuff. And you should be good with this. Yes, ma'am. Yeah, let me write this down first and then you can go. So, let's see. My book's over here. Let's see, 1 to 32, right? Is that what I said? Now, you're like, 32 problems, but you're not doing any math. All you're doing is looking and writing down whatever. Well, they're asking you some questions. They're not just asking, everybody listen? They're not just putting a picture there, you tell what it is, okay? They're asking some certain things about it. But it still shouldn't take you very long. Even though there's 32 problems, it's not going to be near as bad as what it seems. So it's section 1.7, page 42 and 43, 42, 43, and 1 to 32. Everybody good? All right, there you go. We have finished chapter 1. Well, we still got to take a quiz and a test, but as far as learning new stuff, we're finished with chapter 1. All right. So we got we're going to review for a quiz tomorrow. We'll take the quiz. Then we're going to review for a test, and we're going to take the test. Then it'll be over.